Okay, today it's lesson 1.6. There's a graphing test coming up surprisingly fast. The graphing test, I believe, is on Tuesday of next week. I'm going to double check that before we're done. But basically that means we have today, Thursday, then we have Friday tomorrow. We'll review on Monday, and I'm pretty sure the test is Tuesday. Okay, so it's not like I'm going to teach you a ton of stuff. It's just you haven't been tested yet on graphing a lot of what we've talked about. Like the inverses, you know, we talked about the graphs of them, but you were never tested on that. So anyway, let's just do this thing one at a time. I hope you know a few of the parent functions. This one's the parent quadratic. Did I hit all the right spots? No. You have to. This is a graphing test. You can't just sketch. So how are you going to hit all the right spots? Well, you have to think it through. 0, 0 is definitely on x squared. I'm graphing this. And then I put in 1 and I square it. 1 squared is 1. If I put in 2, then 2 squared is 1, 2, 3, 4. 2 squared is 4. And you go and put in -1 and you square it and you get 1. And -2 squared is 4. And anyway, there's your parent parabola. And do you remember how these things are getting shifted? The stuff on the inside is left, right, and the stuff on the outside is up, down. And so let me take just a moment to remind you how those work. Okay, so here's inside versus outside. If you have this, first of all, you're kind of cooked if you don't know the absolute value, like shape. Generally, you need to know what the absolute value shape is. It's a V shape, okay? And this one's been moved 3 different ways. It's been moved this way, and then that thing has also moved it. Would you please write down for me what you think the 3 things were that we did to this? Now, we've been tested on this before, but we've never been actually tested on the graph of it. But first, we've got to remind you, where have we moved this thing? Write these on your iPad. Okay, Mr. K, read me your list. Okay, that is a reflection officially over what? Which axis? All right. And you could have said an up, down, or a vertical reflection. Do you remember the high-vo saying? It's horizontal on the inside and vertical on the outside. So that's a vertical reflection because it's on the outside. This is also on the outside of our grouping symbol. So those 2 things are vertical on the outside. All right, so reflection over the x, or you could say a vertical reflection. What else is there to be done, Mr. K? Left 4 and up 5. Does the order matter? Oh, yes, it does. Now, you have 2 choices on that. You could start on the inside and work your way out. That's my recommended method. But if it's a multiple choice test, you have to be prepared that the answer could also be done from the outside in. Now, that makes it sound like anything goes. Totally not true. There's only certain orders that are correct. All right? So if I start on the inside, then, of course, that's this. And now what does that mean first? Left 4. Number 2 has to go to the outside, right? And of those 2, the things on the outside go in the order you would expect them to go in, which is, please excuse my dear Aunt Sally order. Parentheses should be first on the outside here. There's no parentheses. Any exponents on the outside? No. And is there multiply and divides? Yes, there is. That is like multiplying by -1. So that has to come next. And that's that reflection. I'm going to call it a vertical reflect. Okay? And then the last thing on this one, there's only one thing left, so it's not too hard. It's the up 5. That's if you start on the inside. I want you to start on the inside. Okay? I think it's the best way to do it. And number 2, it's way easier if I'm grading them and you all do it the same way. It's really messes with your head to try to do it all backwards. Okay, so start on the inside if you can. If it's a multiple choice test, the answer could be from the inside out or from the outside in. All right, now let's do one where it's a little more complicated. Oh boy. Having technical issues here. See if I can use the mouse to do it. There we go. Okay. So here's another one. One, two, three, four, 5 things to be done. And if you start on the inside, there's only one right order to do it in. Everybody list 1, 2, 3, 4, 5. And see if you can get this in the right order. I'll pause for a second while you try that. And in a moment, I'll have you share with the kid I pair you with who's near you. Okay, so we've determined that a lot of people had different answers than each other. So what is the right order? Well, if you have to start on the inside here, then there's obviously 2 things on the inside. Does the order matter? Yes. Do you remember that when you're on the inside, you do things in the opposite of normal order? Okay. And now, this also can be confusing. This is a multiply, and this is an add, but this is a parenthesis, and don't parentheses always go first? Yes, but when you're on the inside, you do things in the opposite of normal order. So if parentheses are normally always first, then they can't be first. So you have to start with the 2. So this has to be that 2 first. How many of you did the 2 as first? Yeah, it's only 5 of you would have had this right. I'm not just making this up. This is the way it has to be. You have to do it in the right order. Okay, that 2, then that is a, let's see, it's not a stretch. Seems like it's twice as wide. Okay, remember it's HIVO, horizontal on the inside, vertical on the outside, and this is also vertical on the outside. And it's a horizontal, not stretch, it's opposite of that. It's a horizontal shrink. Horizontal shrink factor 1/2. Because if you use a shrink factor of 2, you're like saying, you know, 2 is normally what you use to double things. So horizontal shrink factor of 1/2. All right, number 2, the second thing. Well, that's the other thing on the inside, which is the +4. And by now you know that that means left 4. Okay, then we move to the outside. When you're on the outside, the order, of course, matters, and we do it in the normal order because you can trust the stuff on the outside. So there's 2 things, this and this. Now, I kind of lied to you just a little bit. I said that there was only one right answer, but you actually can do, if you're starting on the inside, once you get to these 2, these can be done in either order. But I did, in the past, tell you that it's smarter to stretch before you flip. And so I would have wanted you to do the stretch first. So that'd be a vertical stretch factor 3. But again, it can be reversed with this one. And this negative is a reflection, so it's a vertical reflect. CTION, vertical reflection. And then the very last thing that's left is the 5, and that's up 5. Technically, you could reverse these 2, but I think stretching before you reflect is a good idea because it's easier. All right, that was tough. Did anybody have it in exactly the order and saying it the exact way I said it? Okay, so don't underestimate. These are kind of easy questions, but hey, we got a lot of smart kids in the room and nobody had it exactly the way I was looking for. Let's do one more like that and see if we can handle it. Y equals negative square root of negative 2 parentheses x minus 1 plus 8. There's once again 1, 2, 3, 4, 5 things have been done to this function. So give me a 1, 2, 3, 4, 5. Start on the inside. And remember, when you're on the inside, you got to figure out the normal order and do it in the opposite of that. Okay, we went from 0 people getting exact right answer. Let's see if we can get at least half of you who don't make any mistakes on this. Please write them down. Do not compare with your partner yet. Wait till you both got it done, or you'll bias them. Okay, I'm sensing you're doing better. Let's see. On the inside here, what's normally first is parentheses, so that cannot be first. So of these two, technically they're tied. But I generally want you to do stretches before you do flips. But again, it can be reversed here, but you should start with either the stretch, which is a horizontal on the inside, vertical on the outside, high vo. Okay, so it's a horizontal, and is it a stretch or a shrink? Horizontal shrink. S-H-R-I-N-K. For some reason, my brain could not process an S at that moment. Horizontal shrink. Okay, and that's factor 1/2, because you use a fraction when you're shrinking stuff. Okay, number 2 is a horizontal reflection. And yes, you could say a reflection. If it's horizontally, it'd be going over the y-axis, but I think it's easier to say horizontal. Number 3, that is on the on the inside still. There's the third thing after these two are done is you go in there and you go right 1. Anybody got it right so far? Cool, then you're likely to finish it right. The fourth one is you go to the outside and you do this one first because it is a multiply by -1, and multiply happens before add. So that is a vertical reflect, and that leaves only one thing left, the +8, and that's up 8. Who had it perfect this time? Sweet, went from nobody to almost everybody. Cool. That's the order. That's one important thing that's on today's homework and on the test too. Of course, everything we teach you is on the test, pretty much. Okay, now let's talk about if you actually had to graph this. Let's say you went brain dead and totally forgot how to do x cubed. Some of you probably have forgotten how to do x cubed. If you had to graph this and you didn't remember what the shape was, and by the way, the shape is like this. That's what x cubed kind of looks like. Okay, but if you had forgotten that, do you get that you can always graph these with an XY chart? Every graph we give you can be done with an XY chart. So I just want to remind you of that by asking you to make me a few points on this right now. You can pick any number for x you want. I recommend picking small numbers, like 0, 1, maybe throw in a negative. Okay, would you find me several points that are on this graph? I will ask people for what points did you pick on your XY chart. Write them down. I will call on random people in just a moment. All right, so let's see. Third row, 5th person. That would be Miss Gordon. Well, give me a point. If you stick in 1, which goes right here, then what'd you get? I agree, 1,3. Raise your hand if 1,3 was on your list. Okay, good. Mr. D.L. in the back row, tell me another point. 2, and then when you put a 2 in here, 2 to the 3rd is 8, 8 to the 3 is 24. I agree. Raise your hand if you had 224 on yours. Awesome. Okay, and then who threw in a negative point? Good. Give me a negative point. Do you mean you put in an x as negative, or do you mean you got y as? Okay, good. So x was negative what? Negative 1, and then you got what? Yes, it is. Good. -1, -3. I was thinking to be positive, but you're right. Raise your hand if you had that one on your chart. Okay, awesome. Does anybody have one more negative I can put in? What you got?
-2.
And you get -24. Good. Why isn't the negative getting canceled by this cubed? Because it's negative times negative times negative, and that keeps it negative. All right, good. So if you forget what the parent shape is, that's always can work for you. And you just have to graph those points. Over 1 up 3. Over 2 up 24, like way up there. What if I put in a 0? I'd get 0. Okay, and then it just goes like that. Okay, that one you didn't get shifted left or right, but of course, if I did, you'd be able to handle it, I think. All right, now let's go back to that worksheet we started talking about at the very beginning. So everybody get that up on your screen. I'll tell you which ones you can skip on here. I am going to do the first couple. I know some people probably have started their homework, so I'll leave number 1. You got basically 3 graphs here where you can sketch problems 1, 2, and 3. Okay, if I was going to do this one, for instance, You could graph the parent and then stretch it and then move it down 2. But personally, I think you'll more likely get it right if you do this. Make an XY chart. It's your choice. You get to pick. But if you're going to graph the parent, which is a parabola, and then stretch every point, you're going to have to do 6 things right. And take all those points and move them to the right spot. And then, when you move everything down 2, you have to do 6 things right again. Now you got to do 12 things perfectly right in a row. I'd rather make an XY chart. So it's up to you. You do need to know what they mean because we asked you in those questions about, like what order should you do it in. You need to know where to stretch things and all that. But when you're actually graphing it, I think XY charts are the bomb. They're really good. Okay, so let's actually do one here. I'll graph this 3x squared minus 2 just with a little XY chart. And I'm going to put in 1, and I get 1 squared is 1. 1 times 3 is 3. 3 minus 2 is 1. 1, 1 must be on my graph. If I put in 0, 0 here, it's going to make 0 minus 2, which is negative 2. And is a couple points enough? No. 2 points determines a straight line. To get a complicated curved line, you need several points. And I'm going to say at minimum, you go for 5 points. If I can't possibly mark it wrong for having only 5, if you have 5 points. If you have 3 points, I dare you to know exactly where that graph's going. It's like, okay, it has 3 points, but I'm not sure where it's really going. If you have 5, you really start to get the pattern, There's 5 points. I know where that graph's going. All right. So I'm going to get another couple points. I'm going to put in 2. So I put in 2 squared. 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. 2 comma 10 must be on my graph. And I'll put in negative 2. Negative 2 squared is going to be exactly the same thing, 10, because it ends up being, when you take the negative 2 squared, you get 4, just like when you put in the 2 squared, you get 4. Okay. All right. There's your idea on the graphing problems. Now let's talk. We already talked about the order for those other kind of problems. So this is a little bit big, though. On problem 2, why don't you skip H as in hamburger? On problem 3, why don't you skip, again, H as in hamburger? And I think we got, doing them in the right order, we got 4 of those. That's probably okay to have 4 of those. Those are hard, and you need to practice them. Okay, let's talk about number 8. Do number 8 with me right now. It's different than the others because it starts out with a function that's already been moved, and then we move it even more, I guess you'd say. All right, transform the graph of f into the graph of g. How do you get from here to there? Do you get that this, compared to where it started, is already been moved 2 to the left? But by the time we're done, it needs to be 4 to the right. It can't be to the left at all. So which way do we have to move it to make it do that? Yes? You want to move it to the left 6? I think you got it backwards. Because this one's already gone left 2, and we want it to go to the right to end up there. This graph, which right now is shifted 2 to the left, and so it kind of looks like this. That's this one. It needs to end up here, which is over here. Do you get, we start with the red one and we have to go to the right? Okay, so we want to go to the right 6. I think you just had your left and right mixed up there. So there we go. So it starts here. It needs to end as the green one. So you just have to move it to the right, and it turns out 6 places. So describe how to go. You just say right 6. That's it. Don't have to even write an equation for it or anything. How do I get this guy to move and change into that guy? Well, he's already been moved 1 to the right, and he needs to end up 3 to the left. So you got to move him a lot to the left compared to what he is in the first place. I'd make a little sketch and say, here's my parabola that's been moved 1 to the right. Looks kind of like that. And he needs to end up being 3 to the left and upside down. It's like that. So where do we got to move them? We got to move them this way, not just 3 spots, but actually 4 spots. And then we have to reflect them. So you just make your 2 little things. First do this, then do that. Does the order matter? Oh, yes, it does. Now, since I said you can start on the inside or on the outside, you can actually do it either way. But I'd suggest you start on the inside. Please, always do the inside stuff first. Okay. Make little pictures. If you get stuck on those, they even confuse me sometimes. Once I get a picture, I'm good. And I think you will be too. You'll be reminded of that. A picture is worth 1,000 words saying. All right, there's a few too many of those. I'm thinking we can chop off number 12. And this one, again, I feel like you got enough. We'll have enough practice if we skip number 16. No, wait. Let's skip number 15. So 12 and 15 just got culled out of the herd. So skip 12, skip 15. All right, now how do you do this kind? You take the parent points, which are these points, this and this and that and that. And I suggest you do use the parent point technique on this. You start by graphing the parent one. So I'm going to go to -2, -4 here and put a dot. 0, 0, put a dot. 2, 2, put a dot. And 4, 0, and put a dot. And then I would move each of my dots according to what this says. So I would move them, start on the inside, I'd move them 1 to the left. So grab every dot and you move it 1 to the left. There, everything just moved with it, which is kind of nice. If you use your scissors tool, you can do that too on your iPads. You know, make a scissor thing around it, grab the whole thing, slide it to the left. What's this 2 in the front doing? Well, it's just the same as if it was at the end here. So just move that 2 to the end instead, +2 at the end. So that means the whole thing up 2. So I'm going to grab these guys and move them up 1, 2. There. And now I'll do my stretch. Do you see what trap I just fell into? I just did it in the wrong order, and I will get the wrong answer now. Order matters. Okay, so I started by moving to the left one. So now I'm going to go back there. I was here. I was good when I had moved to the left one. Do I have to really do the times by 3 first? Yeah, you do. Otherwise, you'll get the wrong answer. How do I times each of these spots by 3? Make them 3 times taller. Well, you figure out how tall they are in the first place. This one right here, for instance, I got a height of 2. So I make it 3 times taller than that. 3 times the 2 makes 6. This has no height, so I don't move it at all. This has no height. This one is already down 5. It shouldn't be down 5. What happened to that? It was supposed to be down 4. I think I just goofed. Down 4 and left 2, and then I moved it to left another 1. So it should be right there. Sorry about that. Okay, now I got to make my black points, which are all 3 times as tall. So if it was down 4 before, did it just change again? It's like they got gremlins on the board. I swear I just had this point right there. How did it move? Weird. Okay, so now I'm going to triple that and go from down 4 to down 12. So that's going to be about here. So here's my new shape. It's taller and stretched up down compared to what it was before. And then the last thing I do is move the whole thing up 2. Pay attention to the order. It's really huge. Move them all up 2. That's the parent points. Forget that. I got to move the black points up 2. There we go. They're getting out of line a little bit, but that's the idea. All right. Now, could I have done this by making a list of the parent points and then like doing that to the x's and then doing this to the y's? Yes, you can, but I have to say I don't think it works as well in this case as just taking the parent points and actually doing the move and the switch, the flips and all that stuff to them. All right. That is all the new material I have for today. This is about graphing, and the graphing test is, again, You got one more day of new material, and then on Monday we do a review, and then you have a test on Tuesday on it. I'm going to take this last question. Yes?
With regards to the homework, there's like 10 more pages.
Okay, there's apparently more problems. I may be skipping on the homework. I will pause for a second and see. Okay, so I need to explain how to do things like problem number 25 and number 26. Now, if I actually do these two problems for you, it's not going to help you because then you don't have any homework where you can practice it. So I have to show you one that's like it but different. And pay attention because this is not easy stuff. I'm happy that somebody reminded me these were on here. So I'm going to show you this in another context. So would you please right now stop working on your homework, put your pencil down. I normally don't do this, but I need your full attention for the last, we got about 5 minutes left in class. I probably need 3 out of the 5 minutes, so pay attention. Okay, iPads should be shut or a screen off, one or the other. Okay, this is called a sawtooth function. And there's no special reason it has to be like sawtooth. It can be like curves, but basically it's some function you don't know the rule for. All right, now how do you do an absolute value of that function? If f of x is my original function, then if I go y equals absolute value of the f of x, I obviously did something to it. Would you agree that the absolute value makes things turn positive? Things that were negative become positive when you absolute value them? Okay, so this one takes all the y's. Wouldn't you agree that f of x is also the same as y? We've used f of x for y forever, right? Do you get then that by doing the absolute value of the whole thing, you're taking the y values and you're messing with them, doing something to the y's? Well, look at this graph. Where do I have negative y values that would get changed? Well, y is this way, right? The positive y values don't do anything different, so the ones that are up in here, all the stuff that's up in there doesn't change at all. It's only where y's were negative that they're going to change. So I'm going to take this little part of the graph right here, which all had y's that were negative, and I'm going to do the opposite of what it normally is. It's going to go like this. So when you do the absolute value of the f of x, you're doing the absolute values of the y's. You make all your y values change to positive. So the whole answer looks like this red answer. Actually, red on red is terrible. I'm going to make it green. There's my final answer for my original function. Okay, my original function, just to clean all this up here, looked like that. And again, when you do the absolute value of the y's, you take the stuff that was down here and you make it move. So your function stays the same here, but goes like that. That's the absolute value when you put it around the f of x. Of course, there's another way to do it, and that's if you have y equals f of x, but you put your absolute values just on the x's. Okay? Now, do you get that I'm going to mess with my negative x's? My negative x's on my parent graph here are the ones that are, here's the way x goes, right? The negative x's are in this little zone right here. Okay, now this part usually gets confusing for people because you don't just reflect that. Think about that. It would reflect back over into this area. There's already stuff there. We don't do that. I know it seems like many of you would think we should. But what you do is you say, okay, if I have to change this area, I'm going to erase this area. And then this part of the graph right here gets reflected. And there's my final answer for my function. Okay, now why? It's a really good question to ask. Why? Why did it reflect over there? Do you get that f of x had an answer for every number I put in for x? Now when I put in negative numbers for x, it thinks, because he absolute valued it, that I put in positive numbers for the x. So when I'm about to put in like a negative 3, it thinks I put in positive 3. So it goes over here, looks what the answer is. That's why those answers need to be over here. Okay, when I put in like -4, it thinks I put in a 4. So it thinks that the answer should be down there. So you copy it over here. So bottom line is this right here needs to get reflected over there. We will practice that again before you're tested on it. But you have 2 homework problems, and those 25 and 26, that are good practices of that. And that's all I have for the video for today.